Hello everyone, welcome back to my YouTube channel. Myself Akank Shree from Industrial College of Engineering, studying in Information Science. Today we'll speak about latches and flip-flops. Let's give introduction about what is latches and flip-flops. Latches and flip-flops are basic elements for storing information. One latch or flip-flop can store one bit of information. The main difference between latches and flip-flops is for latches, their outputs are constantly affected by their input as long as enable signal is asserted. In other words, when they are enabled, their content changes immediately when the inputs change. Flip-flops, on the other hand, have their content change only if they're either a tracing or falling edge of an enable signal. What is flip-flops? A flip-flop in digital electronics is a circuit with two stable states that can be used to store binary data. The stored data can be changed by applying varying inputs. Flip-flops and latches are fundamental building blocks of digital electronics systems used in computers, communication, and many other types of systems. Both are used as data storage elements. In other basic storage elements in sequential logics, but first let's clarify the difference between latches and flip-flops. What is latches? Latches in VLSI is a short circuit low impedance channel generated between the power and groundless of MOSFET circuit, resulting in high current leading to IC damage. It is caused by interaction of parasite PNP and NPN transistors of BJTs. This results in a structure unresolvable silicon controlled rectifier. These create a positive feedback loop by short-circuiting the power and ground rails, resulting in excessive circuit and perhaps it causes the damage to the device. And the types of flip-flops, there are four types of flip-flops in digital electronic circuit. SR flip-flops, JK flip-flops, D flip-flop, and T flip-flop. Let's understand each flip-flop one by one. In SR flip-flop, this is a common flip-flop among all. This is simple flip-flop circuit as set of input and reset output input. In this system, when you set S as an active, the output Q would be high and a Q would be low. Once the inputs are established, the wiring of the circuit is maintained until SR goes high or power is turned off. Second one, JK flip-flops. In simple words, J and K input are different, that is high and low. Then the output Q takes the value of J at the next clock edge. If J and K both are low, then no changes occur. If J and K are both high at the clock edge, the output will toggle from one state to another. JK flip-flops can function as a set or reset flip-flops. Third one, D flip-flop. The D flip-flop is better alternative than very popular digital electronics. They are commonly used for counter and shift registers and input synchronization. In D flip-flop, the output can be changed only at the edge clock. If the input changes at the other time, the output will be unaffected. Next is T flip-flop. A T flip-flop is like JK flip-flop. These are basically single input version of JK flip-flops. This is a modified form of JK flip-flops is obtained by connecting input J and K together. It has only one input along with the clock. These flip-flops are called T because of their ability to complement their states, that is, toggle, hence they are called toggle flip-flops. Next is flip-flop applications. In this article, we have summed up the different types of flip-flops that we use in electronic circuits. You can find various applications below. First one, frequency dividers. These flip-flops are used in frequency dividers so that the frequency can be divided equally. Counters and storage registers. As the flip-flops are also known as storage devices, it can be used to register the various types of storage input and output values. And and we have learned in the previous flip-flops that it can be acts as a shift registers, data storage, and bounce elimination switch. Next, we'll know about what is latch. A latch is similar to flip-flops but has no clock input. It can change its state as long as the inputs remain stable. Latches are level-sensitive devices that respond to logic level of their inputs. Latches in VLSI is a short circuit or low impedance channel generates between the power and ground rails of the MOSFET circuit, resulting in current leading to IC damage. It is caused by the interaction of parasite PNP and NPN transistors. Types of latches. Latch or set reset latches or SR flip-flops. JK flip-flops, toggle flip-flops, delay or data flip-flops. Applications of latches. Digital systems use switches to input values and to control the output value. For example, a keypad uses 10 switches to enter decimal number 0 to 9. When a switch is closed, the switch connects physically, vibrate or bounce before making a solid contact. The switch bounce causes the voltage at the input of the switch to vary between logic low and high wave and average. Short duration before settles to a steady state. And let's know about difference between latches and flip-flops. Flip-flop is a basic bi-state device. It has two stable states that is 0 and 1. Whereas latches is also bistable state who also represent 0, 1. It checks the input but changes the output only at the time defined by the clock signal or another control signal. It checks the inputs continuously and responds to the change in the inputs immediately. It is an flip-flop is an edge triggered device. It is an level latches is an level trigger device. Flip-flop uses gates like NOR, NOT, and NAND are the building blocks of flip-flops. These are also made up of the gates, but different ones. Flip-flops are classified into asynchronous and synchronous flip-flops. Latches are classified in as no such classifications. Flip-flops forms the building block of many sequential circuits like counters. These can be used to design sequential circuits but are not generally preferred. A flip-flop always has a clock signal. Latches does not have a clock signal. Flip-flops can build from latches. Latches can build from gates. Example D flip-flop, JK flip-flop. Example SR latch, D latch. Design consideration. When designing PCBs for flip-flop digital circuits, several considerations are paramount. First, proper signal integrity and timing must be maintained to ensure reliable operation. Power distribution and decoupling capacitors should be strategically positioned to minimize voltage fluctuations and noise. The relevant timing parameters of a flip-flop are set up time to setup and clock to delay TQ. These parameters are conventionally defined to minimize the sum TDQ is equal to T setup plus TCQ. And let's know what we understand in today's presentation. Flip-flops and latches are essential components in digital circuit electronics. They enable memory storage, sequencing, and synchronization operations. Understanding their types, applications, and designs considerations is crucial for successful circuit design. A latch changes the output when the input changes. In contrast, a flip-flop changes the output when the input clock signal changes. The latch is sensitive to applied input signal, but when it only enabled in context, the flip-flop is sensitive to applied input and clock signal. Thank you.